So Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. This is the fourth chapter titled Inferential Statistics. Previously, we looked at descriptive statistics. This is inferential statistics. Inferential statistics is another stage of statistics. I do not say that descriptive statistics is much easier, but it is different. For example, when you look at descriptive statistics, you are looking at frequency and percentage. You look at those basic information of your respondents. Yeah? You don't do anything and you don't do any analysis that involves correlation, differences, comparisons, changes, which are more critical. I do not say it is more complicated. It's just more in terms of the depth of the study. Yeah. Descriptive is the surface. Descriptive is the surface where you look at the number of gender, the number of education background, who are they. You get to know your audience in terms of those demographic background. Even so, let's say you look at items measuring communication effectiveness. You can have descriptive. You look at the mean score. You look at the mean score of each item. For example, you look at communication effectiveness using Likert scale. So you have 1 to 5 scales. You look into the mean score. What is the average score for those items, each item measuring communication effectiveness? That is descriptive. But when you want to relate, you wish to relate those items with another items, communication effectiveness and self-esteem, for example, then it becomes inferential statistics. You go to another stage of analysis. The important concepts of inferential statistics, which two important concepts before we venture more into the world of inferential statistics. The first one is sample and population. The second is probability. The sample and population is each respondent. Who are they? What is the smallest size of population? Population is the bigger. Population involves bigger number. Probability is the probable or the likelihood of your samples to be analyzed in your study. Population. What do we mean by population? As I mentioned previously, is the bigger group, or I would say the main group. The main, not the main of your study, but the main group. Which population you look at? It is the entire set of things of interest. If you are talking about USIM, students from USIM, that is population. It's big, thousands, which may not answer your objective clearly, because you may look into specific case, specific issues. So this entire population is important, because we have to understand that basic information of this population is similar in terms of age, in terms of academic background. We know that USIM students is different. USIM students have different backgrounds with UKM students. Having understood those differences, therefore, that entire population is important to be known, is important to be recognized. Before you select specific groups, which is the sample of your study. While sample is the part, I'm not saying the small part, it can be big, but it's a part of the population about which you actually have information. 100, for example, here we have 100 men and women who answered an online questionnaire about healthcare usage. So small part, because it's 100. You talk about students, how many students? Thousands, 7,000. So 100 is what? 0.7% of the whole population. That 0.7, is it 0.7? 7 times 7, 49. No, 100 of 7,000, 70. No. So it's like 10%, not 10%. 0.1, which is not equivalent at all with the population. Yeah? We need to see this sample. Now, why do we learn about sample? Because the only part that you will have your study on is the sample. Having had the sample, this data, the findings will or can be generalized into the population, can be representative, of the whole population. When you have your findings, for example, that the student self-esteem highly associated with communication effectiveness for your sample, these findings can also be applied to your population, because you basically have calculated that sample can be generalized, can generalize the whole population. That sample is adequate. Yeah?
Jojo nak tidur ke? Tapi tak nak tidur. Buat apa kat
Okay. Why samples instead of population I studied? I already mentioned this now. It is usually more practical. Population is too big. Yeah, population is too big. 7,000, that's fine. But for other universities, can be 20,000, 10,000. And within the time frame you are given, it is very unlikely for you to, or it is not feasible for you to have your study within the time frame. Your thesis is about 6 years. Even for PhD, it's like 1 year after you pass your some call CE comprehensive exam, some would say qualifying test. So very impossible for you to actually to reach those population, because it's too big and too costly. Too much time you're going to spend on data collection. The goal of research is to make generalization. Yeah? So we are hoping that that small sample can generalize. The findings can be generalized into the whole population. What do we mean by generalization is because we will predict, we will have predictions about population or events in general. When we have the sample from FEBU, for example, that sample can be perhaps if you have adequate numbers, that findings can be generalized into the whole population, the whole system students. Yeah, much of social and behavioral research is conducted by evaluating a sample of individuals who are representative of a population of interest. That's why at least at the basic background, at the basic information, they should be similar, not too far. If you're talking about age, yeah, the students, university student range from 19 or 18 to 18 to 26, 20 or 30 for degree. For degree. That's why when we talk about degree, it must be specific with within the degree students. Because why? If you involve master students, that master student's age can be 40 years old, can be 35 years old, or even 55 years old. It's too far from the samples you are looking at. Yeah, so it's too far. The age is too far. The way they think is different. The way they practice is different. If you're talking about self-esteem, their self-esteem are different. So it cannot be similar. That's why when you have that sample should be adequate in terms not only about the size, the number of respondents, but also the background, the education background, the interests are similar. How do we do sampling? How do we select our sample? Yeah, the first one is random selection. Method of choosing a sample in which each individual in the population has an equal chance of being selected. Yeah. Random number table. Usually students use that specific group, KBA, TBA1 to TBA10, for example, uh, which include or which provide equal chance of being selected. If we talk about KBA1, the whole the number of the students in KBA1 has an equal chance to be selected as part of our study. That's what we mean by equal chance. And the second one is haphazard selection, method of selecting a sample of individual to study by taking whoever is available or happens to be first on the list. This method of selection can result in a sample that is not representative of the population. We look at first come, first serve. Who is available, then he will be the respondent. Who has the interest to answer the question, and then they become the respondent. The likelihood of being selected will depend on the availability of the respondents. If they turn up into the class, yes, they got the chances to be selected. But if they don't appear and they don't come to the class, so they don't have the chance to be selected in the study. Population parameter. Population parameters involves mean, variance, and standard deviation of the population. Population parameters are usually unknown, and can be estimated from information obtained from a sample of the population. From the smaller group you are looking at, can provide estimations of how that population look like. Who is the population based on the information you're getting from the sample. The sample parameters involve mean, variance, and standard deviation. And then the sample parameters are calculated from known information. What do we mean by known information? you have all the details of your sample: age, education background, experience using phone, and then the interest of your respondents. You have all the information. Okay. The first one is sample of population, and second is probability. What do we mean by what do we mean by probability? Okay. It is expected relative frequency of a particular outcome. Outcome, what do you mean by outcome, is the term used for discussing probability for the result of an experiment. Expected relative frequency is the number of successful outcome divided by number of total outcomes you would expect to get if you repeated an experiment a large number of times. Yeah. Long-time relative frequency interpretation of probability is the understanding of probability as the proportion of a particular outcome that you get if the experiment were repeated many times. So these terms you must remember clearly. What do we mean by outcome? Expected relative frequency and long run relative frequency. So what is the difference when you have the outcome and then you have this particular sample? Steps for figuring probability. Okay, hold on, yeah. Step for figuring probability. First, you need to determine the number of possible successful outcomes. The estimation. Even from FPBU, for example, you have in your batch 226. So what is the estimation of your figures for unsuccessful outcomes? How many samples would you have in return? So you have determined the number of all possible outcomes, including successful and unsuccessful, and then divide the number of possible successful outcomes by number of all possible outcomes. Okay. You have this is example. You have a jar that contains 100 jelly beans. 9 of them are green. What is the probability that you can pick that green jelly beans out of 100? Okay. The successful is 9. The possible outcomes is 100. Because we have only 100 jelly bean. So the probability that you can have that 9 green jelly beans is 9%. If we talk about the probability of taking the green jelly beans, 9%, it means you may not be able to get the whole 9 jelly beans in green color. Very unlikely. Unless the probability is 50% or 89%, then the likelihood to have all jelly beans in the green color is there. Probability cannot be less than 0, cannot be 0.09 or greater than 1. What do you mean by 9? Oh, sorry, why 1? 1 means 100%. So when your probability is more than 1, means the possibility are very general, or the probability is very has a very too big, too overwhelmed. Yes, it's overwhelmed. Sometimes with probability of 0 has no chance of happening. Sometimes with probability of 1 has a 100% chance of happening. Even though there is only 1, so that means 100 chance of happening. So cannot be less than 1. Sorry, cannot be more than 1. It cannot be because 1 is 100%. So here is 9%. 0.9 is 9%. 99.9, yeah, or 9.9 is 10%. So one is 100%. But usually when we divide, let's say, let's try we divide 90 of jelly beans let's count. Let's say 90, 90 divide 90 divide into 100. So there's miscalculation here. 9 divide into 100 is 0.09. Yeah. Okay, there's a correction over here. Let me try to figure this out. So 9 over 100 is 9 over 100 is 0.09. I cannot fix this. Okay, this is wrong. It should be 0.09%. is less than 1. Yeah? So 0.09. Very unlikely or very impossible for you to get the 9 of the green jelly beans. But if you have 90 green jelly beans out of 100, 90 divide into 100 is 0.9. 0.9 almost to near to 1. 0.9. 0.9 is almost 1. So it cannot be more than 1. Even you have 100 is 100% equivalent to 1. So that, what do we mean by probabilities? If someone asks you, what do we mean by probability? Probability is the chances, is the size or the chances that you will get the samples out of your population. So this is P italic is a symbol for probability. Or I usually use the word significant value. Yeah, because the significant value refers to the P. P means probability. When your probability is usually written as a decimal 0.1, but can also be written as fraction 9/100 or percentage 9%. So when your P as a probability is less than 0.05, what do we mean by less? It cannot be less than 0.05. If it's 0.09, yes, sorry, it cannot be 0.09 is acceptable for probability is must be less than 0.05 or some 0.01 to be significant, so the p value should be less than 0.05. Purpose of inferential statistics to enable researcher to make statement or summary or decision about the population based on the sample. Inferential statistics wishes to enable researcher to make statement or summary or decision on the unseen data based on the empirical data. What do we mean by unseen data? Based on the unseen data, we can make predictions. To enable researcher to make statement or summary or decision on the large group based on data from the small group. This is what the generalization means. You can make the generalization from the small group to the larger group. So there are two main purposes of inferential statistics. The first one is to make estimation or assumptions. Then for your hypothesis. Hypothesis is also like a kind of predictions. What do you expect from the findings? Hypothesis testing is usually indicated by H1 or null hypothesis is H0. So now alternative hypothesis, we have like H and then number. If you have 5 hypotheses, then we have H1, H2, H3, H4, H5. That number H1 must be smaller. You have the in Microsoft Word, you can see the X symbol, but underneath is smaller to the next one. You can check on your Microsoft Word. So a statistical assumption, a set of parameters, guidelines indicating the conditions under which the procedures can be most appropriately used. Every test has own assumption that should not be violated. There must be some assumptions of what will be your findings, or what will be what you will find in the outcomes. There are four main assumptions of inferential statistics. Okay, the first one, these two procedures. The first one is random sample. Second is characteristics are related to true population. Those samples or those individuals or those respondents should be related to true population. If you're talking about USIM student, make sure that the smaller size has all registered with USIM. They must be USIM students, or otherwise it's not valid. The third one is multiple random sample from same population provide similar statistics that cluster around true population parameters. They must have similar background, at least for the qualifications before they enter to use. And number 4, can calculate the sampling error associated with them with the sample statistic. It can be calculated. Normal distribution is a continuous probability distribution. Data in the normal distribution are measured in terms of standard deviation from mean and called standard scores or zero. Data in normal distribution, normal curve, are measured in terms of standard deviation from mean and are called standard scores or z-score. Characters of normal distribution: first, it is continuous probability distribution. Second, is symmetrical or bell-shaped. Bell-shaped is normal, with the mode, median, and mean are equal. So when they say bell-shaped, means the number of mode, median, median and mean are equal. From the first on the left, and then when you have the curve stop at the right, they have the equal chances. Normal distribution is a continuous probability distribution, symmetrical or bell-shaped, with the mode, median, and mean are equal. The distribution contains an infinite number of cases. The distribution is asymptotic. The tails approach this is very, I don't even understand this, abscissa. What do you mean by abscissa? It's a range from negative to positive infinity. The tails approach. I will check later on. Range from negative to positive infinity. About 95% of distribution lies within two standard deviation from the mean. Within two standard. 95% on about 95% of the distribution lies within the two standard deviation from the mean. So that's all about inferential statistics. So understand what do we mean by inferential statistic, what is the assumptions before we go to the hypothesis. Okay, for inferential statistics, random sample, 4. There are 4 main assumptions for inferential statistics. Okay, this is normal distribution. Okay, So that is about those inferential statistic. I will open for discussions.